this is Sarim Khan, and since today I am back with my new video. So since many days we were studying about the concepts, about the theories in laws of motion. Okay, so since many things new we have learned in laws of motion, already 3 videos I have made over laws of motion. So today is a video that is totally based over the numerical problems. We'll be doing numerical questions related to the acceleration. So it is totally related to the acceleration, and we'll try to bring in this all the concepts or the whatever concept is used in those kinds of problems related to acceleration. So since this is our question number first in this video, so this question is asking to us that the acceleration of the block is, first of all, this figure has been given to us where it is said that the surface is smooth. It has been also written, and here is 10 newtons, here is 20 newtons, and the block is of mass 10 kg. Then here we can see that one thing we can notice, as I have told you, that whenever the surface is said to be smooth, means frictional force is 0. Why it is 0? Because frictional force, or F, let it be small f, we write as mu n, and smoothness means that the coefficient of friction is 0 or the mu is 0, means F is equals to what? 0. 0 into n is 0. Frictional force is 0. So if we want, then since here the surface is smooth, so we can write that the friction is here 0. Okay, so here what we can see, now we have to, according to this, we have not to, okay, while solving this question, while making the FBD of it, so we'll not take frictional force in this. Now first of all, we'll try to draw the FBD for it, since already we have learned how to make FBDs, how to make the free body diagrams in my previous videos. So first of all, let this be the block, here be its center. Now from here down force is acting mg. Okay, after that from upward direction it is acting n. Mg value means 10 into 10. Suppose that the g value is 10 meter per second square, because already we have studied g equals to what? 9.8 meter per second square. But even then, sometimes in calculations we take 10 meter per second square, so it is already not given here, so let us take. So mg is, then of course then we can tell mass is 10 kg, g is 10, so here mg is 100 newtons. Okay, after that n will be also 100 newtons. So here we can see that they are equal and opposite, but they are actually not example of action-reaction pairs, because it is acting over a single body. But Newton's third law of motion says that no, the force should act between two bodies. And here Newton's laws of motion says many things that it does not relate to this, because since we know that the nature of forces should be same, but here one is weight while the other is normal force. So here we can see next force acting over this is, suppose here is 20 newtons. After that what is given? Here is 10 newtons. According to this we have to solve now. So mg and n will try to cancel each other. Since suppose I have to find out the sigma fx. Sigma fx is what? Sigma fx will be, suppose I am trying to solve it using vector notations also. So this is 20 I cap. I can write here 20 I cap. Here I can write minus 10 j I cap. After that here I can also write it 100 minus 100 actually j cap, and here is actually 100 j cap. Okay, so sigma fx means sum of the x component of all forces. So how many x forces we have which are present to the directly x axis? Because of mg and n, x component is 0. Of 20 and 10 there will be something none equals to 0. So 20 I cap, first of all 20 I cap. Now plus minus 10 I cap. So that will be minus 10 I cap. So sigma fx is 20 I cap minus 10 I cap, which is equals to what? 10 I cap. It means that the net force is acting in net force in this kind of situation is 10 newtons in which direction? In positive x direction. After that sigma fy. What is sigma fy? First of all 100 j cap. Now plus minus 100 j cap. So which is equals to what? Which is equals to 0. It means sigma Fy is 0. So according to this, if we are just going, so we can just get here that acceleration, since force is what? Second law of motion gives us that the net force is, actually here is net force. Net force is mass into acceleration, or acceleration is what? Acceleration is net force divided by mass. So if we put our values here, so what actually is net force? 10 I cap. So 10 I cap divided by mass 10 kg. Then this 10 I cap is in newtons. So this will be 1 I cap. Okay, actually this is 1 I cap. So 1 I cap you can also write as I cap. It is same. I cap meter per second square. I cap meter per second square. Actually here should be actually just 1 meter per second square, but I am writing according to the vectors. I am trying to show the direction. So here what actually shows the magnitude of acceleration? Magnitude of acceleration shows, okay, what is actually 1 is present, because behind I cap 1 will be hidden. After that I cap is showing the direction of acceleration. So you can also write it as 1 meter per second square if you do not want to add vectors in this. But actually here magnitude of only acceleration we have to tell. So we can tell that the acceleration magnitude is 1 meter per second square, or if acceleration, then 1 meter per second square towards which direction? Towards the positive x-axis direction, or simply I cap meter per second square. So magnitude, let us put here 1 meter per second square. Hence this is the correct answer. So in this kind of case where the since we know frictional force is 0, because the surface is smooth, or the coefficient of friction is 0, and if coefficient of friction is 0, then the frictional force is also 0. So hence in this case the acceleration of the block will be 1 meter per second square. So since this is our question number 2 in this video, so this question is again related to acceleration, since in starting I told you that our today's problems will be related to the acceleration. Then in this question it is asking that the acceleration of the block is, this figure is given, and again the surface is smooth, and when the surface is smooth means mu equals to 0, or frictional force is also 0, friction is also 0. So here what this is telling, that first of all we put a 10 kg block, okay, any block of mass 10 kg on a smooth surface. Later in this direction, by making angle 45 degree with the horizontal x-axis, I apply any force 20 root 2 newtons, okay, over this block. Later what I say, that find out the acceleration. What is the acceleration of the block? So what I will do, first of all I will try to make a free body diagram. Then here first of all we will try to make the free body diagram. Here which forces? Here mg is again, mg is what? It is again 100 newtons. Then upward what is? N is again 100 newtons. After that here a force is getting applied, F is what? 20 root 2 newtons. 20 root 2 newtons. So many forces, 3 more forces we have. But later what I say to you, that resolve this force in 2 parts, x component and y component. No requirement of making angle 45 degree. Just like this angle is what? Is 45 degree. No matter of making angle 45 degree. Only what is that find out the x component of this force, then y component. And if we do such, then here x component is what? X component is f cos theta. So which is equals to what? Because with theta it is making angle. Already I have also told. So f cos theta is, f means 20 root 2 into theta is 45 degree. Cos 45 degree 1 by root 2. Root 2 and root 2 cancel. So which is equals to 20 newtons. X component. Later what I say, find out the y component. So y component will do. So here it will happen f sin theta, y component. So which is equals to what? 20 root 2, f is again 20 root 2 into sin theta. Okay, sin of angle theta. Theta is again 45 degree. This angle is 45 degree. Okay, so sin of 45 degree is same as cos 45 degree, 1 by root 2. So into 1 by root 2, root 2 and root 2 cancelled, which is equals to 20 newtons. Means if I want to, here I can do generally more better. So here which force is acting? 100 newtons. First of all this 100 newtons plus plus what? This force 20 newtons. Here is what? Here is only 100 newtons. Okay. Now here is what? Here is 20 newtons. This we got 100 and 100 cancel. Here is 20 newtons. Here is 20 newtons. So finally we can call that here is also 20 newtons. And again here is also 20 newtons. What is the acceleration of the block? Acceleration. Suppose what is the suppose I am saying to you acceleration in x direction. Acceleration I write as force divided by mass. Force in x direction. Suppose I am saying of x direction. So force divided by mass. So force what is in x direction? 20. 20 divided by 10. So meter per second square. Sorry, here is kg actually. So which is equals to what? So finally here we'll be getting 2 meter per second square. Acceleration in x direction is 2 meter per second square. And later what I say, acceleration in y direction is what? Force in y direction divided by mass, which is equals to force in y direction 20 newtons. Divided by what? 20 newton divided by how much of what is mass of the system? 10 kg. So this is also again what? 2 meter per second square. So generally now what I am saying, no need to first of all write 2 meter per second square in x direction, then 2 meter per second square in y direction. Only what let us write here, since it is a subjective type, what we'll be doing, only acceleration is 2 meter per second square, only so much. Now first of all total acceleration will do at is equals to what? Root of this square. So first of all we'll do here 2 square plus 2 square, which is equals to root of, now 2 square is 4, 4 plus 4, which is equals to what? Root of 8. Now root of 8 will do first of all, so root 8 will do 2 root 2. So actually acceleration in this direction, so actually 2 root 2 we are getting, then no need to write 2 root 2, only will be writing 2. Why 2? Because in each direction it is same, 2 meter per second square in x direction, so 2 meter per second square in y direction. So only what will be writing, if we are only writing 2 meter per second square, so it is a meaning as in x direction and y direction, the acceleration is 2 meter per second square. So we can also write as 2 meter per second square in x and 2 meter per second square in y, or if you want simply 2 meter per second square, and that is the correct answer. So since this is our question number 3rd in this video, that is again an acceleration question. Okay, again we have to tell acceleration in this, and this question is asking to us that if inclined plane is fixed and block is smooth, then the acceleration of block is, this is again subjective type question. So here we have been given an inclined plane. After that angle of inclination is 37 degree, and it is given that the inclined plane is fixed, means it is not moving anywhere, and the block is also again smooth. Then what is the acceleration of the block? Okay, since we know that here there will be some acceleration of the block A in this direction, of course there will be, then here what actually is acceleration of the block, what is the value of A? So here since only what we'll be doing in this is, first of all mg will be acting in this direction, here is mg. Okay, here is mg. After that what is, suppose here n will be acting, something, whatever be the value of n or mg. Okay, suppose we do not have to write it at the present time, only suppose that just downward direction towards the negative y-axis, okay, mg is acting, and here by making some angle n is acting. After that what is said in this question, we can find many new and interesting thing in question. It does not look, but actually we can get here that if I make just an anti-parallel line to n, just like here in this direction, what is the component of mg? What is the component of mg in this direction? So for this angle theta I need, and I say that this angle theta is 37 degree, because if this angle is 37 degree something, this angle should be also 37 degree. So this angle is 37 degree. Actually it was not looking in the question, but we have to apply our concept, and we can tell if this is 37 then this is also 37. Easily we can tell if we know the mathematics. Then what is the component of mg in this direction? I say that the component of mg in this direction will be mg cos 37 degree. Okay, mg cos 37 degree. After that, what I say, if this is mg cos 37 degree, then this is towards the, since we know that here what kind of axes we are taking. Generally, if we try to put our axes on this, so here it will be such x, y and y, negative y. So actually this kind of axis we have to take on the inclined plane. So if I say to you to find out the minus x component, actually x component of this mg, so how will you do? If this is mg cos 37 degree, then here will be mg sin 37 degree. Here is mg sin 37 degree, means the component, actually mg itself is a force. So this force, what is the component of this force towards the negative x-axis? Mg sin 37 degree. I say, after that, since we can see if here is mg sin 37 degree, and in same direction, what is the acceleration? Actually, we can see that in same direction, acceleration is also. Then according to this, if we are seeing, so we can easily apply our second law of motion in this. What we had learned in second law of motion, that vector f is m times vector a, or vector a is vector f divided by m. Acceleration we have to find out. So actually what is acceleration here? If we are using this identity, so what is F, net force here? So acceleration is here, and here force is also getting applied. So mg itself is a force, right? So I will write that mg, actually mg sin 37 degree, this force is equals to what? Mass, okay, mass times what? Times the acceleration, okay, times acceleration. This I am writing that mg sin 37 degree is equals to what? Is equals to m times acceleration. According to this, we can call that acceleration is what? Acceleration is like this, you can do this divided by this, or if you want then like this also you can do force divided by mass. So force, what is actually force is here mg sin 37 degree. So mg sin 37 degree divided by m. So this will come, which is equals to g sin 37 degree. Now sin 37 degree value, okay, that is 3 by 5, which is equals to 10 into 3 by 5. So 5, which is equals to 6. Acceleration is 6 meter per second square. Finally we got the answer that the acceleration of this block is 6 meter per second square. Hence this is the correct answer. So since in this video, this is our question number 4th. So since question number 4th is really interesting question, okay. So it is slightly different type of question, but in question number 4th, it is again of acceleration type. So we can see that a horizontal force F of 20 newtons is applied on the smooth block of mass 1 kg. Then the acceleration of block is, this figure has been given. First of all, since it has been given that the block is smooth block, it means that the block is just smooth and of mass 1 kg. Later horizontally, just like here 20 Newton force is getting applied. This angle of inclination of the inclined plane is 37 degree, and we have to find out the what is actually the acceleration of the block. So what we'll be doing here? First of all, since that the block, okay, we can see that the where will the weight of block be? In this direction. In this direction mg will be, of course. Then according to this, if we are going in this direction mg is, then here if we are doing, since here now n will be, now here this angle will be what? This angle is 37 degree. Then here is mg cos 37 degree. Here is mg cos 37 degree. Then here what will be? Here is mg sin 37 degree. Directly we can say, such as here mg cos 37 degree, then here mg sin 37 degree. Now what we can see, if we have to find out the x and y component of this force of 20 Newton, since we are taking what? This is what? This is x-axis, x and minus x, y and minus y, because in our everyday life generally wherever we use physics, so generally we use such x minus x, y minus y, but here little we have to do it at some little angle of 37 degree. We have to turn this graph, so here such will be using. Then now if we are trying to find out the x and y component of the force of 20 Newton, Obviously, if we want this angle, what is that? This angle. Of course, here will be that. Here will be f cos theta or the 20 cos theta. What actually is the angle theta? This angle will be 37 degree. Obviously, if this angle is 37, this is 37, this will be also 37 degree. Of course, we can get. And if this angle is 37 degree, what is this component? This component will be 20 cos 37 degree. Of course, then 20 cos 37 degree we can easily evaluate. 20 cos 37 degree means 20 into 4 by 5. So this is in 4 times, so 16. Here is what? Here is 16 newtons. Okay, 16 newtons we got. Means here 16 newtons force is getting applied. mg sin 37 degree, what is? M is 1 kg, g is of course 10 meter per second square. After that, then this will be 10 sin 37 degrees, so 10 into 3 by 5. So into, which is equals to 6 newtons. 6 newton here, 6 Newton in this direction. So actually this is minus 6 I cap newtons because it is just negative. Here's negative. If you want, then first of all you can find out the 16 newtons and 6 newtons. First you will be finding out the numerical value, and after that you will form the equation later put, or if you want then directly you can just form the equation and put, because since we know that net force F net is what? F net is what? F net is m into a. Now according to this, what is net force in x direction? So here's what? 16 newtons. You can write 16 newtons, or if you want then you can also write it as 20 what? 20 cos 37 degree minus mg sin 37 degree minus mg sin 37 degree, which is equals to what? Mass. Okay, mass we can put 1 into acceleration, so a. Okay, so mass already we have multiplied to the acceleration. So now if you want, implies that 20 cos 37 degree we have evaluated 16 newtons minus, so then mg sin 37 degree equals to g sin 37 degree, because m value is 1. So if we want g sin 37 degree, so g in this we have got 16 newtons minus 6 newtons is equals to a. So a is equals to what? 16 minus 6, then we are getting that from here a value easily we can get, that is 10 newtons. So okay, actually here this is meter per second square. Okay, here is meter per second square, because actually here was what? Here was Newton and here was Newton. So here also Newton and Newton will come. But even then here acceleration unit we can't just put Newton. We'll be putting it as 10 meter per second square. Meter per second square always and always, because Newton is just the SI unit of force, while meter per second square is the SI unit of acceleration. It means that the acceleration of the block is 10 meter per second square. So here we can write 10 meter per second square. Hence this is the correct answer. So this was mainly my today's video over the topic numerical problems over the acceleration. So thank you to you.